Welcome to the fourth module of engineering geology. This module is titled as mass wasting and causes of landslides and their remedial measures. I am Professor Mohammad Masroor Alam from Department of Civil Engineering, AMU, Aligarh. In this module, you will be able to know about what are the causes of mass wasting and mass movement. You will come to know about different kinds of rock mass failure and different types of landslides. You will learn about different processes which are involved in the landslides and how to quantify them so that we can have remedial civil engineering measures to control this problem of landslides. Landslide is a general term which takes into consideration different kinds of failure of earth material. The earth material which is exposed to the earth surface, that is subjected to weathering and erosion, which is termed as mass wasting. This weathered and eroded material constantly moves down the slope, and this movement is called as mass movement. Sometimes this mass movement becomes faster than normal, and it becomes sometimes spasmodic. When it becomes spasmodic, faster than normal, then we call it landslides. Now, landslides can be technically classified into many different types depending upon what kind of material is involved and what kind of movement is involved. The material which we have in nature, it is either rock plus soil, which we can call debris, and pure soil or earth. The movement which we can have, it can be free fall, which is called as fall. It can be toppling fall, that means the material is moving on very high angle slope. Sometimes it is in contact with the ground and sometimes not. The movement may be in the form of sliding along a planar surface, or it may be in the form of slump along the curvy planar surface. Sometimes this material, especially the earth and debris, if it is saturated with water, then flow-like conditions can also take place. So if we see the rocks, then rocks can have fall. We may have rock fall, we may have toppling rocks, we may have sliding rocks, but as such flowing rocks are not possible. Similarly, we may have debris fall, debris toppling, debris slide and debris flow. If pure earth is involved, then we have earth fall, earth slump, earth slide and earth flows. There are some special materials also involved in the landslides. For example, if purely snow is involved, then it is called as snow avalanche. If volcanic ash is involved, then it is called as ash flow. If it is in cold form and if it is in hot form, then it is called as nui ardente. The causes of these flows may be natural or it can be anthropogenic also. The natural causes are mainly high angle slope, especially more than the angle of repose, steep slopes, heavy weight over the top of the slope, presence of weak zones along the joints, presence of clay, salt, serpentinite, etc. along the joint, heavy rainfall, and seepage of water along these joint planes, earthquakes, etc. The anthropogenic causes involve excavation along the hill slope, maybe for construction of houses, maybe for construction of road or railways, mining along the hill slopes, blasting, and deforestation. The landslides, they are as such natural phenomena, and in fact they are the very first step in the formation of soil, which is most important material for human beings after oxygen and water. Because if there is no soil, then there will be no agricultural activity and we will not be able to produce anything. So the end product is soil, which starts from the landsliding. So as such, landsliding are a very natural process. Yes, if human beings, they come close to the natural sites of landslides, then they will be subjected to problems, and then the same landslide hazard may take a new dimension in the form of landslide disaster. It is one of the natural disasters which normally take place on any slope, even sometimes on slopes which are less than 5 degree in permafrost region, where we have earth failure and a type of skin earth failure that is called as solifluction. Now, depending upon what material is involved, soil or rocks, we can have different kinds of landslides. For example, in soil, it is usually failure surface which is curvilinear. This part of the slide is called as a scar of the landslide. We can have left flank and right flank of the landslides. We have toe or foot of the landslides. This is the main failure surface, and these are the smaller failure surface. So we can have in soil curvilinear surface of failure, while in rocks, depending upon if it is sliding along the joint plane, then this becomes slide. If rocks are falling down, then it becomes fall. It all depends that how many joint sets we have. The failure can be toppling failure, the failure can be planar failure, and the failure can be wedge failure. On almost vertical joints, it is toppling failure. On joints inclined towards slope, it is planar failure. And if you have two sets of joints crisscrossing each other, then usually we have wedge failure. Now, as engineering geologists, how can we help the civil engineers to mitigate this problem of landslide? For this, we have two kinds of strategies. One is long-term strategy, in which we try to understand the slopes and try to predict their behavior, and accordingly we go or we adopt measures to minimize or to stop the landslides. The other strategy is that if you have already sliding slopes, then how to stop further sliding. So that is the active mode, in which we have to install some features onto the slope so that the movement is restricted. For long-term strategy, we have to go for landslide hazard zonation, where we have to see the slope which is in question, and then we have to divide this slope into 4 different categories. A slope with no possibility of landsliding, a slope with very low possibility of landsliding, a slope with moderate possibility of landsliding, and a slope with very high possibility of landsliding. This can we do by incorporating different aspects of that slope, which include the geology of that slope, that is, what kind of rocks are there, what is their attitude, that is strike and dip, what is the deformation structures present on that slope, especially the shear zones and nature of joints, what is the groundwater condition onto that slope, what is the vegetation present on that slope, how that slope has been used in past. So all these mapping have to be taken up, which include geological mapping, hydrogeological mapping, groundwater mapping, land cover mapping, land use mapping, and then all these maps have to be synthesized, and accordingly we come up with the different kinds of landslide hazard zones. Depending upon what kind of probability of slope failure is, we take measures to minimize the effect of landsliding. We have many different methods to quantify the slope. For example, there is a method given by CBRI that is called as landslide susceptibility scores. We have another method which is given by Bureau of Indian Standard, which is landslide hazard evaluation factor. We have another method which is an international method which is called as slope mass rating. These methods, they have identified different parameters and they have given some values to different parameters, and they have summed up those parameters and found out these scores. The landslide susceptibility score is calculated by a formula that is summation of rank into weightage. Summation of rank into weight. So actually 9 factors have been identified. Each factors have been further classified into different categories and they have been given weight. So for example, the 9 factors are hydrology with rank 9, slope with rank 8, overburden thickness with rank 7, slope and discontinuity relation with rank 6, joint and fractures with rank 5, weathering rank 4, rock mass rank 3, lithology rank 2, vegetation type rank 1. Each of these ranks, they have been further classified into categories. For example, hydrology, which has been given rank 9, has got 3 categories: flowing, wet and dry. The flowing condition has been given weight 9, wet condition has been given weight 6 and dry condition has been given weight 1. Accordingly, slope, overburden, slope and discontinuity relation, joint and fractures, weathering, rock mass, each have been classed into 3, 4 or 5 categories, and each category has been given numbers. The more problematic conditions have been given higher number. So if we multiply the rank with the category weight, then we will get value for all these 9 factors, and ultimately the result will be, if it is more than 300, that means the susceptibility is very high. If it is 200 to 300, the susceptibility is moderate, and if it is less than 200, then the susceptibility of the slope for landsliding is less. Similarly, Bureau of Indian Standard has taken 10 different causative factors and they have given it different numbers termed as landslide hazard evaluation factor. The 10 causative factors are lithology with LHEF number 2, structure 2, slope morphology 2, relative relief 1, land use 1, land cover 1, hydrological condition 1, rainfall 1, landslide incidence, past incidence 2, slope erosion 1. So totaling 14. Now if we calculate this LHEF for all these factors, and if the value comes more than 10.5, that means the landsliding zone is 5 and it is very highly prone to the hazard. If it is 8.41 to 10.5, then it is zone 4, it is highly prone to the hazard. If it is 7.1 to 8.4, it is zone 3, it is moderately prone to the landslide hazard. If it is 4.9 to 7, then it is category 2, it is low susceptibility to the hazard. And then if it is less than 4.9, then it has got very low hazard. Slope mass rating is an international method in which this rating is done on the basis of first calculation of rock mass rating, that is RMR, plus 3 different factors F1, F2 and F3 plus F4. So we have to calculate first RMR, then these 4 factors. F1 is a factor which is related to the difference in orientation of slope and the most important joint surface. It is a relationship between strike of most important joint surface and the slope surface. F2 is related to the inclination of the joint. F3 is related to the difference in angle of slope and angle of dip of the joint. And F4 is related to the method of excavation by which slope was created. If we calculate this, we can have values starting from less than 20 to 100, and this whole numbers can be classified into 0 to 20, that is 5th class, 20 to 40 4th class, 41 to 60 3rd class, 61 to 80 2nd class, and 81 to 100 1st class. If we have class 1 slope, that slope need not undergo any remedial measure because this is a very strong slope. It is not going to have landsliding more than often. It is a safe slope. But as and when these values come down, that means slope is amenable to landslide. So if we have SMR values 20 to 40, then we call it bad and unstable slope, where the failure probability may be 0.6. If it is less than 20, then it is completely unstable slope and the failure probability is 0.9. Depending upon SMR values, we can also suggest what kind of measures, civil engineering measures we can take to stop the landsliding, which includes from spot bolting to scaling to formation of toe ditch to formation of pattern bolting, formation of rock fencing, formation of retaining walls, re-excavation, and sometimes formation of retaining walls and concrete walls with buttresses. As the slope becomes poorer and poorer, more of civil engineering measures have to be adopted to control the landsliding. The important methods methods by which we can check the problem of landsliding. It starts from very simple one to very difficult one, which involves a lot of civil engineering measures and thinking. The simple one can be suspended netting to catch the rock within the net. It can be chain link fencing. It can be net in catenary. That means you have a net above the road. If any rock slides, if falls, then that net can catch that. We can have formation of fence, which may be barbed fence, which can stop the rolling rocks to protect your road. We can have tow ditch, in which if there is any rock fall, that rock fall comes into that ditch and should not go to the road or railway track. We can have different kinds of walls, stone walls, to protect our roads and railway tracks and houses. Then we have measures which are called as ground support. In ground support, what we do, we use rock bolts and rock anchors, rock dowels, shear keys to tie the sliding rocks across the probable failure surface. This needs lot of drilling and putting the steel rock bolts into that drill holes, or putting of rock anchors through the bore holes. Sometimes it is 40 feet deep. The main purpose is that we should tie the sliding rocks together so that there is no movement. The other methods which are called as mass support, that is erection of gabion wall, erection of concrete wall, erection of retaining wall all along the slope, making of dental masonry, and making of concrete walls or retaining walls with buttresses. So these are the different methods which are normally used to protect slope. Now, as you know that landslides are a very natural process and phenomenon, though they are aggravated by anthropogenic activities. To counter this problem or to minimize the effect of landsliding, we have to have a very good idea about the landslide hazard zonation, which we can work out with the help of different kinds of mapping involving geological condition, hydrogeological condition, meteorological condition, land use and land pattern, vegetation cover, and then we can quantify this in different ways, either adopting Bureau of Indian Standard or adopting the CBRI method, or we can go for estimating the susceptibility of landslides using slope mass rating. Once we quantify the problem of landsliding, we can also suggest the civil engineering measures which can vary from spot bolting to pattern bolting to erection of retaining wall and to even modification of slopes. That's all for this module. Thank you.